Hello, Professor Neil. My name is Ankit Ori, and today I will be presenting my project, which is removing backgrounds of pictures using Python and OpenCV library. And with that, we'll continue to the next slide. In this presentation, first I will go over what my project is and then how it should work. And then I will go over the three main components of the OpenCV library which helped me achieve my output for this project. And then we'll go over the conclusion for this presentation, and then I'll go over my code and OpenCV code, and at the end I'll go over the demonstration of the project. OpenCV is a powerful and versatile library for computer vision tasks. It provides a range of functions and algorithms for image processing and analysis, including object detection. Object detection is the process of locating one or more objects of interest in a picture, which can be used in a variety of applications such as self-driving cars, surveillance, robots, and etc. OpenCV provides several methods for object detection such as template machine, template matching, feature detection, and deep learning based approaches such as hard cascades and convolution neural networks, which are also known as CNNs. With that, we'll proceed to the next slide. So the first slide is about Hard wavelet method, which is one of the main methods I used to detect an object in an image. Hard cascades are classifiers that are trained to recognize a pattern in an image using machine learning techniques. They are named after the Hard wavelet, which is a mathematical function used to detect edges. The Hard cascade classifier consists of a set of features that are trained on positive and negative examples of the object of interest. During detection, the classifier scans the image using a sliding window and applies the features to each window. If the feature match the pattern of the object, the classifier outputs a positive result. Once the object is detected, you can use various techniques to extract or isolate it from the rest of the image, such as thresholding or segmentation. This will be the end of this slide, and now we'll proceed to the next slide. This slide is about edge detection, which is one of the main components I had to use to detect an edge of an object so that I can see where the object is. So to remove the background of an object in an image, you can use thresholding. Thresholding is a technique that converts an image to a binary image based on a threshold value. The threshold value is set such that pixels with intensities above the threshold are considered part of the object, while pixels with intensities below the threshold are considered part of the background. Once you have the binary image, you can apply a mask to the original image to remove the background pixels. Thresholding is a simple and fast technique, but it may not work for images with complex background or lighting conditions. Now let's proceed to our next slide. This is the last main method I used, which is image segmentation to complete my project, and we'll go over that right now. Image segmentation is the process of dividing an image into multiple regions based on their properties, such as color, texture, or intensity. There are various algorithms for image segmentation, such as k-means clustering, weight-band segmentation, and graph-based segmentation. Once you have segmented the image and identified the object and its background, you can extract the object region and remove the background region to obtain a clean, isolated image. Image segmentation can be more accurate and robust than thresholding but it can only be more computationally expensive and require more fine-tuning. In conclusion, OpenCV provides a range of powerful tools and techniques for object detection and background removal in images. Whether you're working on a simpler or complex computer vision project, OpenCV can help you achieve your goals with ease and efficiency. By understanding the underlying principles and algorithms of OpenCV, you can make the most of its features and develop innovative applications that push the boundaries of computer vision. This will be the end of this presentation. Now we'll go over the code, OpenCV code, my own code, and then the demonstration of the project, which will complete this presentation. Hi there, welcome back. So this is my code. By the way, I developed this code on Linux because I found it helpful and easier because I wanted to learn Linux because I've been using Windows my whole life, so I wanted to develop something on Linux. This way I can develop an application on Linux now, which I'm really familiar with after this project. And it was easier for me to download OpenCV on this. So before I started off with this project, I downloaded OpenCV on Linux so I could use OpenCV library in the project. And then my code begins by importing the image, which we were gonna remove the background from. By the way, this is the image we're working on. So as you can see in this picture, this man, there's a man in the image and it's green background. We're gonna remove the green background so that the result is that the final product should be that there's no green background and the object has been detected and extracted out of the image. Now let's proceed to review the code. So in this line number 7 and 8, we're just doing the SHV color space. We're calling the CVT color function, which is that's built-in OpenCV function to get the HSV colors. And then we process the image by using one of those IMOW built-in functions by CV2 library. And once we have that, we do the edge detection. So keep in mind that these numbers that I had to come up with, I had to play with these numbers in order to get the right edge detection so that I don't miss any pixel at the same time. I don't get any extra pixel out of the background because I want it to be accurate as possible. So I had to play with these numbers to get these numbers and then display edge result. So in between, I do the display of edge detection results. And after that, we do the Gaussian blur. As we studied in this class, I had to use that in this code. And again, I had to play with these numbers so that I can come up with the best numbers so that I don't lose the intensity or clarity of the picture. At the same time, I get the best results possible. Then we have to blur the image in order to remove the background pixels that we do not need. Then we do thresholding, just like we talked about in the presentation. That's one of the main product methods I used in this. And then we do MIM right. That's just processing the picture, processing the processed picture so that we improve the clarity of the picture. Here we clean up the picture just by deleting all the extra pixels we do not need. And then we set the lower and upper bounds for the low intensity colors and high intensity colors. And then we do bitwise masking, and then we display the image. So that's the whole code. And we, like, as I mentioned, we used OpenCV's built-in functions. And now here's the result. And let me just show you the picture one more time. So here is a picture. There's a man, green background. We're gonna extract the object out of this picture so that we only have the person, the object inside the picture, and we remove the background. And let's do that here. So here you can see the final result. I called my code using the Python 3 function, the built-in function in the Linux terminal. And here you can see we were able to extract the object out of the image, and now there's no background. and this is my project. Thank you for listening and watching. Uh, and it's been a pleasure taking this class. I got to learn a lot of new stuff, which is a lot of cool stuff. And I want to thank you for teaching all the good stuff. I look forward to taking you in for a different class in the future. Thank you so much. Thank you for listening.